Germany, Garmisch-Partenkirchen in the mountains. I'm sorry I couldn't come. I'm just in the middle of writing my PhD at Southampton, and this is the introduction to it. I learned to program in 1979 at my father's business school on a DEC 2020. This led me to philosophy and then back into computing as I ran out of money. And then I worked at Alta Vista, and where I developed the Babelfish machine translation engine service. And then I worked at Sun Microsystems doing research on the semantic web. And I've been very, I developed web ID authentication there. And I've been implementing LDP and solid clients and servers. So now I'm doing my PhD. What I want to do is very quickly give the core reasons for decentralization by starting from philosophy. And I think one needs to go there in this direction in order to really find the foundations for justifications for decentralization. We can start with knowledge. This was the first question, one of the first questions that Socrates asked in ancient Greece is, what is knowledge? And he gave a definition that's well known. It's justified true belief. That is, if you know something, it has to be true, you have to believe it. And well, Socrates added it has to be justified. In 1981, a very interesting modal logical approach to the definition of knowledge came along, and it had the three clauses. You know that P, if you believe that P, and this is the key one, if it weren't the case that P, then you wouldn't believe that P. This type of definition could not have appeared before the 70s because counterfactual reasoning developed by David Lewis in his book in Counterfactuals, and that's really a neighborhood semantics, would have, without that type of logic, it would have felt that you were trying to define something with something even less clear than what you had before. But with a very clear mathematical definition of counterfactual reasoning, which requires you to think of possibilities as spheres around the actual world, possible worlds in having a distance relation to our world. For example, if we look at the picture here, we have at the center the actual world I, and then propositions are thought of as sets of possible worlds. We have two sets of possible worlds, phi and psi. And if phi were the case, then psi would be the case. Is defined as in the closest possible worlds where phi is the case, then psi is the case. If that's true, then your sentence is true. So if kangaroos had no tails, they would topple over. That would be true. If in the closest possible worlds where kangaroos have no tails, they topple over. And that is indeed the definition that David Lewis gave in Counterfactuals in 1973. So this brings us to the limits of knowledge that Nozick brought into a kind of science fiction version to explain, to defend his analysis. And he imagines Alpha Centaurians coming and taking people at night, kidnapping them, taking them to a spaceship, taking their brain, putting it in a vat and connecting it to a supercomputer that's far beyond our imagination. And then simulating it in such a way that the brain believes it's having experiences veridically that it isn't actually having. We found films that deal with this like The Matrix. And the relevance to what we're saying here is that the problem is that if we allow this type of situation, then we can't, the question comes, how can we know it all, right? If I don't know, if I can't distinguish that I'm not in a matrix, and if knowledge is to know that P is to, well, this would have been a previous definition and one that's used in many types of modal logic is To know that P is to be able to exclude all possibilities that not P. Well, if I can't exclude that I'm a brain in a vat, then the question comes, how can I know it all? And we're at skepticism. And so in order to show how this counterfactual analysis of knowledge works, in the case of knowledge, we can look at how it works with something simple like knowing that one has £5 in one's pocket. So if someone knows they have £5 in pocket, they have to know that they have to have £5 in their pocket, they have to believe that they have £5 in their pockets. And if they didn't have £5 in their pockets, then they wouldn't believe that they have £5 in their pockets. And that actually works, because if I didn't have £5 in my pocket, then it's likely just because I spent them on something. And to bring in the Alpha Centaurians is way out and is unrealistic and unnecessary for for everyday reasoning. So by creating a distance relation between possible worlds, we can both accept that there are possibilities we can never exclude from and at this from our thinking. We can never know that we're not in that situation, and yet we can know simple things, like and quite a lot of things, as long as we don't need to contemplate these extreme scenarios, which we can contemplate out of interest in philosophical reasoning. So we can relax now, right? Well, no. Well, what about if, well, yes, we can relax, but let's just consider the situation where Alpha Centaurians might be in the area. In that case, we would have an epistemological war. We wouldn't know, we would have to deal with a situation where we would not know if we are dealing with, when we receive a phone call, if it's a real phone call, if when we're speaking to someone, it's we're actually speaking to the person we're speaking to, whether when we're reading news it's true or it's fake. And these two ads are of course humorous and sponsored by various fitness organizations. There was a recent one that came up in England. And so they're humorous, right? So we still think that we're all right. But aren't we perhaps actually in this situation? Aren't the aliens already in the cloud? Because if we've externalized our memories and placed all of those memories in the cloud, how can we tell if our memory hasn't been altered? Perhaps we think that what we put in the cloud isn't fat enough to be of interest of those who are keeping it. But what about the huge marketing industry that's feeding us individualized dreams based on our externalized memory? They need not change the past if they can direct our future by changing our feeling of the space of possibilities to worry about. And for larger institutions that depend on externalized memory to function, the problem is even bigger. Most institutions are made of individual people that don't know everything that's happening, and will look, when they're trying to deal with a customer, they'll look at a computer screen and try to work and try to pick up from where a previous caller was. And this is what makes telephone support so much better than it was in the 1980s. So in order to address this problem, I think we need a complete stack, that socio-technical stack that starts at the hardware, goes to up all the way up to the social layer. And this is what I want to show. It's important to think about things this way in order to be able to solve some of the big problems that we have in terms of trust and security nowadays. So, if we want to control our externalized brain, we need our hardware, hopefully open hardware with an open operating system on it. That's the bottom layer. Large companies would have the same with their server farms that they should be able to control and be able to know in which legal framework the people working on it are operating, and hopefully, and perhaps even the best for armies and for governments, control the location and of those servers. This was indeed what led to, this type of thinking, what led to the Freedom Box. So we need to be able to control our memory, the hardware, the operating system, and be able to communicate securely when wanted. But we don't just want to be located in this brain that's completely isolated from everybody else. Then we would be back to the 1980s on PCs. So what's missing? What's missing is what's missing is not, what's wrong is not the internet. The internet is a peer-to-peer system, a decentralized system. Every computer can communicate to every computer, and so can the Freedom Box. What's wrong is not the web itself. The web allows many different browsers to connect to web pages located around the web and follow links. So you can choose a browser from a newly developed browser and read any pages. It's not tied to any server. What is the problem are these apps that are tied to certain servers. They create a problem because there's only one app that allows you to read the data. Each app reads only data on one server, and then there's no interoperability at all between these mega servers owning the data. And these might be distributed, they might be using reading web pages, so they're using the decentralized layers at the lower layer, but they're not themselves open. And this means that we can't have we can't each put our data on our Freedom Boxes or our government boxes without in this type of scenario. So that's what has to go. What we want is hyper apps, which I show at the bottom here in red. They're able to fetch data from different companies, different organizations, follow links, and display it in a way that's most suitable to the end user. And there could be many different apps for the same type of data, apps that can merge different types of data. You can imagine a whole competitive landscape of apps here. And this is indeed what Solid is working on. So this is just a way of setting up what Solid is. At the layer above individuals reading and using browsers, we have institutions. And this was first described by Hobbes and the Leviathan and many others. These are the necessary infrastructure to allow us that teach us, that look after schools, about armies, police, and all of these things that turn our brain into a reading brain, and a brain that knows how to use computers so that we can actually use these apps. And these large institutions are themselves embedded into nation states, and these nation states are connected. So to give an idea about how that comes, let's have a quick look at how a URL HTTPS works. So an HTTPS URL like beta.companieshouse.gov.uk, which is the location where all UK companies are registered, or at least public companies. This URL in a browser will point to that website. But the question might be, how do we know that this is the website that we think it is? For example, what about this one? www.mit.go.jp. Is this the equivalent of Company House? Is this a fake? How are we meant to know? And how are they meant to know about our website? Well, we might look at the SSL certificates, but all we find in there are information about the place where it's located. So this is located in Cardiff. How is someone in Japan meant to know where Cardiff is? And if that's got anything to do with the institution that they would like to be able to rely on. In order for that to be possible, we need a web of nations. And that is, we need, if we want to be able to find out, for example, whether the website cooperating.systems is a company in the UK, we need to, that website needs to link to Company House. But say our browser arrives at Company House, how is it going to know that Company House is a legit company? Well, Company House has to be tied to gov.uk. If I'm a UK citizen, then this can be my trust anchor and everything's fine. But what if I'm a French or Japanese or an American citizen? How would I know that gov.uk is the UK government site and not a fake one? Well, these nations need to tie themselves together in the same way using linked data in such a way that if I'm a German citizen, I can find the link to gov.uk, and that will give me a chain of trust. This is not a blockchain of trust. We allow for different points of views and disagreements between nations in order for a Japanese or German or a French web user to be able to have his browser show him the information about the website itself. And the information can be much richer than just where it's located. You can have information about where the company is located, of course, who their owners are, if they've got any problems. And all of this could then be displayed in an external screen, say the Apple Touch Bar, which could highlight any problems and give you a specially secured button that you always know is controlled by the operating system, so that if you want to find out information about a website, you can just click on it. And perhaps the idea would be that whenever you go to the website first, that you've never gone to before, a page or a website that's changed owners, a page would appear in your browser or for any of your apps, giving you information about that you need to know, including the stock value, the owners, and so on. So that's my take about how, by thinking about the internet in terms of a layered stack at which every layer is open and decentralized, we can create a web of trust that ties all the way from the bottom all to the top, and from the institutions back into the hardware, and so we can have a virtuous circle of trust. There's a lot more about this on if you follow this link. All of these were blog posts on the Cybersecurity Southampton blog, and I hope you all have a great conference, and perhaps I hope I can participate too remotely. Thank you very much for listening.